Alright, good morning, good evening, good afternoon. Now we are talking about how momentum is related to, um, basically how momentum is related to elastic and inelastic collisions. Now, let's now perform an elastic collision. What is an elastic collision? Basically, if we have a mass of this ball equals to 5 kilograms, all right, and the velocity equals to 6 meters per second square. All right, and we have another ball is basically 4 kilograms the mass. All right. Actually, we are not performing an elastic collision, which no energy is lost. All right, so equals 4 kilograms. All right, and the velocity equals yeah. So the velocity, for some reason, it's oh no. Let me just restate it back. So let's say it's 6 kilograms. All right, and the velocity equals to 5 meters per second square. Square. All right, and this ball is moving that direction. So it's moving to the right, and this one is moving this direction, moving to the left, and they collide. All right. So what will happen? Well, what will happen basically, the object will not. So the object's gonna stick together. So the object gonna stick together. All right. Because the object is gonna stick together, because it's an elastic collision, so it's gonna come to a stop. All right, basically how we perform an elastic collision is basically through this equation. All right, so elastic collision can be performed through this equation: mv equals mv. All right, which the mass and velocity of the first object must must equal to the second object, or the object that's gonna come to the opposite direction. All right, that is an elastic collision. Collision. What about an inelastic collision? Well, an elastic collision is basically how the object is gonna, how it's basically when an object will not come to a stop. For example, let's say that we have a car going this direction. All right, a car in this direction, and going to the right. So the vector is going to be to the left, and a car on this direction gonna come what? All right, a car this direction gonna go to the right, and the vector is gonna be basically the vector side is gonna be to the right. Well, what will happen? All right, when they collide? But the problem is that the mass of this car is basically 2 less than the mass of the second car. All right, so the mass of this car is basically half. So basically half the mass of the second car, the opposite car, the enemy car. All right. So let's say that the mass is equal to 3 kilogram. I mean, that doesn't make sense. How could a car be 3 kilogram? Let's say the mass is 1,000 kilogram. All right. All right. But the velocity equals to 3 meters per second square. So the car is very slow. All right, let's say that the car is very slow. All right. or let's say that it's 6 kilometers per second square. All right, 6 kilometers per second square. That means that the total of this car is basically the mass times velocity. The total of this car is basically, this one is kg, by the way, 1,000 kilograms. All right, it's basically 6,000. All right, so the total of this car is basically 6,000 kilogram. The mass times velocity at 6,000. You can write it as kilograms square m over s squared. All right. So let's say that it's actually 6,000. All right. So 6,000 total in here, and the other car is basically the mass is equal to we say 6,000. Wait a minute. Let's say. Oh, wait a minute. Let me just. Yeah, anyway, it says 6,000 total, all right. I said it's halved, but yeah. So, wait a minute. So it says 6,000 total, all right. Because the mass of the car is 1,000 kilogram. Now, the mass of the second car, for example, I mean, not the mass. I'm not talking about the mass. I'm talking about the total. So, total MV. All right, you can write it as 6,000 kilograms square over meters time over second square. So we can write it as 6,000 kg square meter per second square. All right, and the other car, the mass of the other car is basically 2,000. All right, so the mass of the second car is basically 2,000. All right, 2,000 kilograms. All right, because we say that the first car is half the other car, half the side of the other car, and the velocity is equal to 7 kilometers per second square. All right. Well, the total is 14,000. The total is 14. So the total is 14,000. Here you said it's a kilogram, kilometers. All right, we said it's a kilometers. So kilometers per second square. All right, and that one is basically 14,000. All right, so 40,000 is 6,000. Guess what will happen for the collision? All right, well, when they collide, what will happen is that the vector of the first car, the car that has less mass, that has less total mass times velocity, which is less total mv, less total momentum. So the car with the less total momentum will shift its direction. So basically what will happen is that this car, the first car, which is the bigger one, the huge one, the higher momentum, the car with higher momentum will shift the small car momentum will shift the small car vector to the left. Although it was to the right, but it's actually to the right, but with less speed. Than the bigger car, which is this one. All right. So that will happen to the momentum. Okay, basically, if I wanted to ride, I would ride it like this. Wait a minute. As for the shift this car to that car, I mean, it's going to shift this the vector of the car that is half the mass of the second car, and will move to the same direction of the car with a bigger momentum, and but with lesser speed, since the energy is lost. All right, since the larger car has lost the car with the larger momentum has lost energy, so it's going to use the excess energy. So it has lost. It's going to use the excess energy to move the smaller car with the smaller car, which has a smaller momentum, to the same direction it goes. So if it's go to the left, it's going to go to the left. All right, and basically, that how the car accidents been. So most of the car accidents will come to a stop. But for example, if most of the car accidents are gonna come to a stop, all right, because the mass and the speed is gonna be the same. But no, actually, restate back. Most of the car accidents will come to a stop because for the momentum, they all both have the same momentum. All right, the momentum is going to be equal when the accident happened. But for example, a motorcycle, let's say a motorcycle smashed to a car, all right, and a motorcycle was moving as a faster speed. So if the motorcycle had moved faster, so the speed of the motorcycle, let's say it's 100 kilometers per hour, and the speed of the car is a 50 kilometers per hour, but the size of the motorcycle is 1,000 kilograms, and when the size of the car is 2,000 kilograms, then then it's gonna be elastic collision, because both the car and the motorcycle, both motors gonna come to a stop, since the momentum are equal. All right. But if it's in elastic, for example, if the motorcycle did not move in 100 kilometers per hour square, and in fact it moved 50 kilometers per hour square, then what will happen is the velocity of the motorcycle. Then what will happen is that the bigger car, which the car gonna move the motorcycle into the same direction, but the car will move slower speed, since it lost some of the energy it already had, some of the momentum it already had. So I hope that helps.